Okay, so we've opened Weka, and now I'm going to the Downloads folder and finding the data set, spam data text. I'm going to open the file, and we've opened the file. Great. So we're looking, we have approximately 8,000 instances, which means 8,000 emails, if we think about what this data set means. And we have two attributes right now for each email. The attribute number one is the text. It can't show this to us because basically what it is a string of all of the text in the email. And the second one is the classifier, which is to say whether it is spam or ham, spam being obviously spam, ham being a real email that is not spam. So in this form, we can't really do anything with the data because everything is in one big text string. So what we have to do is under Filter, still in the Preprocess tab, select Choose, Filters, and Unsupervised Attribute. And what we want to do is do string to word vector. And once we've selected string to word vector, there are a couple of things that we need to change, a couple of the properties. And if you remember, the way to change properties is by clicking in this kind of white text box that doesn't look like it's supposed to be clicked on. Then, well, remember, we're looking at, yeah, so here, this thing that says string to word vector and has all this text in it, I don't know if your screen is working, but it's right next, in the filter box, there's a choose button, and next to it, once you've chosen string to word vector, there'll be a text box. So click in the text box, and I believe in the homework it specifically says what you're supposed to do, but you're going to choose the attribute indices, which is to say we're working on attribute 1, which is text. I'll put 1 here. And we have a couple of other things that we need to do. So we're going to use a stop words handler, which essentially is eliminating the words that are prepositions, words that don't really give any content, that just kind of help the text flow, because they're not really informative in this context. So the homework specifies, I think, to use multi-stop words. But there's other ones like rainbow, which is really popular. But it's important to select one. And tokenizer, which essentially removes characters and like makes words. So let me pull up so this is really an important step. Here in the tokenizer, you need to copy paste this because otherwise you're going to end up with lots of kind of weird characters in your emails. So same here, you're going to click the text box and get into here. See, these are basically the only delimiters, which means like what you're going to use to make a word that will separate words. So it's like space, period, comma. It's not very substantial. Emails have a lot more characters than that. So you put in all of the characters. Someone I think, maybe they got in. Okay. Okay, so we've updated here the tokenizer. And that's everything that we need to do for right now. So, this is annoying. I think this is the right button. Okay. All right, so we've set everything up, and then
Question.
Yeah.
I have a Mac, and I was not able to copy paste, so I had to enter everything, and there's some spaces there, and I was wondering if, because I didn't do copy paste, does that matter?
Well, copy paste wouldn't matter at all, but regardless of a Mac or a PC, you should have no problem getting them in with copy paste. I also have a Mac and it works just fine. I'm not sure. But if you're able to type it in, that's also fine. Does that answer your question?
Yeah, I was just worried about the amount of spaces that are there between the two.
Spaces don't matter at all. Remember, every character that's in this kind of set of delimiters, that's just saying what's going to separate words. It actually, you could have like infinite number of spaces. It wouldn't make a difference.
Okay, that was my question.
Okay, great. All right, so I'm going to apply this, which is exciting. And it's processing the data set. Okay, great. So this is what it's supposed to look like. You have obviously the class, which is the one that one attribute or was attribute 2 before. And then we have all of the words, which is a lot. This is obviously not a word. Kind of scanning, going to remove it because that's not a word. And the way you remove is you just click on the checkbox and then remove.
What are words basically?
So by word, we can use the definition of words generously. I'm going to undo that for a second so you can see what that looked like. See, this is like my 1618 are like weird question marks inside diamonds. I'm getting rid of that because that doesn't make any sense and is just characters. So that's what I'm going to get rid of. WS, which is 1614, like also not a word, but I'm going to leave it in because that's something that was found in an email. And I'm kind of scanning, oh, there, for this other like weird question mark. I'm going to remove that too. Yeah, okay, so getting rid of those. Now what I have to do is, if you look at what these are, each of these variables are numeric. So if we look at AM, there's 2 classes and there are 2 values and they're numeric. It's 0 and 1. But they're not counted as a binary variable, they're counted as numeric. So that's not good for the purposes of building a model. So we need to actually change the designation of these variables. So again, we go into filter and still in the unsupervised and attribute, we're changing, or we're going to go to numeric to binary. What that's doing is taking a numeric variable and converting it to binary. So when we're looking at the attribute indices, that's basically the attribute numbers that we want to include. We're starting with attribute 2, going to the end, and apply. So now they've all changed to A binarized, AC binarized, etc. Which is now, if you look at them, they're not numeric, they're nominal, which means a 0 or a 1. There's not like, if you look before, there was an average of 0 and 1, and that's not helpful. Sometimes like they don't all work. For instance, this is still numeric for some unknown reason, so I'm just going to remove it.
Can you please show us again how you change it from numeric to binary?
Yeah, I'll just undo. Okay, so they are now numeric. You can tell because it says up in the top, numeric. And in addition to minimum and maximum of 0 and 1, it's giving you a mean and a standard deviation, which is just not valuable. Or shows that it's in the wrong format. So then you're going to go up to filter, choose, unsupervised, attribute, and numeric to binary, and close. Then in the parameters, you want to convert from attribute indices, which is like the number of the attributes. Here I'm looking, attribute 1 is the target variable, so we don't want to change that. Actually, it already is binary, so it's irrelevant. But, so we're going to, for me, I'm going to start with 2 to the last and click OK and apply it. And you can see it's converted all of these formerly numeric variables into nominal. And you can see there's still a 0 and a 1, but now instead of having the mean and the standard deviation, we have the count, which is telling us like what percentage of emails that have the word API are which class, or in one class or another. So like if we set the target variable here, it's showing us the count that have one versus another class. So the last step here that we need to do is randomize all of the instances. Because right now in the data set, after we've done that, all of the words that were next to each other in an email are still going to be there. And that could really inform and mess up the model that we're building. So we're going to randomize, which I went to filter, choose, unsupervised, and instead of attribute now I'm going to instance and randomize. And apply. Okay. So I think those were all of the steps that it asked to go through. Just going to make sure that I'm not forgetting anything. We binarized, we randomized, and okay, great. So that's the pre-processing for this first step. And now we have to save it. So save, and we're going to save this as occurrence. That's spelled wrong. Okay, we'll leave it. It's spelled wrong in the homework. All right, that's fine. Great. So we have a saved data set. That means that we have processed it, and if it crashes, which Weka crashes, so, you know, just bear in mind that it crashes, we haven't lost all of the pre-processing that we did. And because we saved it as something else, we can always revert back to the original one. Great. So that's the pre-processing for this problem. And now we actually have to go to building the model. This is actually the easy part. So first step is we go into the Classify tab, and so I didn't do that this time. So I actually, after I binarized everything, I need to check and make sure it actually binarized everything. Here I have this random word that didn't binarize, so I'm just going to remove it. Okay, and now I'm going to save again so that I don't forget that. Okay. So it's great. I'm looking at a whole bunch of nominal variables, which is what I want to see. So I'm going to set the target variable, which is class. Remember, we're trying to predict spam or ham. And go up to the target window and choose from Bayes.
Can you explain why you removed the last word?
Yeah. So the last word, even though I'd gone through and binarized everything, oh, I saved it. Oh, no, it's there. Okay. So this is numeric. After I'd gone through and I'd binarized everything, it still didn't work. And one word, or one out of 1,600 words, is not necessarily that important. I'm looking at it yourself, like this isn't going to give me that much information. And I don't know why it didn't work, so I'm just getting rid of it so it doesn't mess everything up. Like a naive Bayes won't run if there's one numeric variable.
So how did you find that there is one not numeric?
Yeah.
Sorry, that there was one numeric length.
So actually, it's a good question, because initially I forgot that it was going to be there, and I went to try and classify it, And I looked here, and I see something that says NUM, which is numeric, instead of all nominal. And so then I remembered, and I went back here to check, and I see, oh, well, and I click on yourself, and I realize that it doesn't have a binarized tag, and it says numeric. So that's where I'm just going to click it and remove it and not think about it again. Ideally, when you're cleaning data, you want to try and keep as much data as you can. But if there's something that's causing problems and not important, there's a certain point where it's not worth trying to really keep it when you have a lot of data already. Someone is going to like really butt heads with me on that, but at least that's that's the way I feel. Okay, so then we're back in the Classify tab. Sorry, did that answer your question?
Yes, thank you.
Okay, great. So we're back in the Classify tab, and we're going to first set the target variable, which is class. And we're going to go up to Classifier and choose our naive Bayes model. So we select Choose, Bayes, Naive Bayes. And then we're going to go ahead and run the model. Which takes a moment. So just to note, I'm using cross-validation because that's what it says to do in the homework. I think that's what it says. Yes, cross-validation. All right. So now what I'm looking at is kind of what I can use for the evaluation, right? And based on what you've learned in class, what I'm looking for is kind of your interpretation of what you see here. And I'll just quickly go through kind of what's here. So we have correctly classified instances, which means that out of 7,819 emails, 96.4% of them were correctly classified as either spam or ham. You've incorrectly classified 291 of them, which is 3.5% or 3.6%. We're ignoring the kappa, mean square error, all of these things. I don't think you've talked about them in class either. And we're looking at, have you guys talked about ROC area in class yet? Yeah, so then you also have this here to use as something where you can evaluate, is the model performing well or not? But here at the bottom, you have the confusion matrix, which I think you've also gone over in class, and that's also really important when we're talking about a binary classifier. Here, you're looking at classified as at the top, like the model's classification and the actuals. So I have an Excel sheet set up that will kind of talk more about the confusion matrix, but this is going to be really important in interpreting the confusion matrix for like basically the evaluation in this question. So it's really important to look at in this question. It says observe the default cutoff for the classification performance at 0.5. Basically what that means is kind of like we talked about last time, the model generates a model probability of a certain class outcome and then classifies at the 0.5, at the 50% level. And the confusion matrix is based on that 50%. So that's really important to note. But that's something that later in the homework we're going to be able to mess around with. Okay, cool. Does that help? Any other questions about this this question?
I have a question.
Yeah.
So basically, what we are doing here, we don't have the full emails. We have only words that appear in the emails, and based on these different words, we say spam or a normal email.
Yeah. So basically, what the model is doing is we had about 1,800 emails or 8,000. I forgot. I think it was 8,000 emails. We had 8,000 emails, and we took them apart to their individual words. And then we're building a model to predict the probability of spam or the probability of not spam based on the occurrence of any given word or of all these words or multiple words.
So the model knows, like, based on historical information, in which spam emails these specific words appeared more likely.
Right.
More, you know what I mean?
Exactly. So, like, let's just say potentially that emails that had the word video increase the probability of, or let's say like spam emails had a higher probability of the word video occurring, which, like, I don't know why they would, but let's just say they do. And then also valid had a very high probability of spam. And the way that I think you guys learned about the naive Bayes model is that what we're doing is we're like actually putting probabilities together to determine like what's the probability of video and valid occurring in a non-spam or a ham email versus a spam email. And it's going to do that for literally for every email and every word. So it's looking at the combinations of the words and the probability of like each of the individuals and the probability of them occurring together. So it's actually like a pretty cool thing that it does. And if you look at kind of the evaluation, like it's quite effective.
We're running tests on full emails.
Sorry?
So we are running the test on full emails?
Yes, so it's cross-validation. And so it's running the test or the evaluation is on the full data set, but in cross-validation, not using the training set.
Okay, thank you.
Mm-hmm.
I have a question.
Yeah.
Just the page that you are at right now in the assignment, it says consider it both as a model that ranks cases by the likelihood of class membership, and then it says something else about the final use.
Mm-hmm.
What does that sentence mean?
And the final use of the classifier. Okay, so we're thinking about here, like the models, like doing a good job of predicting spam and ham, but then we're also thinking about the use. Like, what is a model that predicts spam or ham going to be used for? And like the answer is it's going to be used for a spam filter. So you want to think about like, how can I say this without answering the question? You want to think about if you're trying to make a spam filter, how are you going to use this model and how well is it going to work for your purposes? And what might you need to change, or what would be the challenge of using this particular model as a spam filter?
And that should be part of our answer.
That's right. That's part of the evaluation. Whenever you evaluate a model, you have to peek forward to the deployment of what you're trying to accomplish with that model. Like you could have great metrics in terms of correctly classified instances, and the model could be completely worthless to you because of some type of limitation in deployment or some other sort of restriction elsewhere in the like data mining cycle. So it's important that you're always considering what you're going to use the model for and how it's going to be helpful or restricted. Does that help? Does that answer your question?
Okay. Yeah, thank you.
Cool. All right, problem 2. So basically, for problem 2, it's a lot of the same steps that we just did in problem 1. But rather than building a model based on occurrence, which is like the presence or absence of any word in a given email, now we're going to use the number of times that each word appears, the frequency. And so we're going to have to go back to the pre-process phase and do it a little bit differently. So I'm going to open the old file, which we're back to the beginning. Oops. Okay. All right. So what we're going to do here is choose filters, unsupervised, attribute, and go back to string to word vector. Same as last time. We're doing almost everything the same, except here is output word counts, we're going to switch to true. We're going to go back to our multi-stop words and make sure that we put back our delimiters. Oops. Okay. And apply. Oh, actually, I don't think that was right. Oh, no, it was. Okay. All right, so now what we have is something different than we had before. We have numeric variables, but this is actually telling us something. It's telling us the number of times that AC appears in an email. Like, for instance, here, the maximum is 17, minimum is 0. So it's actually kind of more rich with information. And we are going to not binarize that because the numeric is actually telling us something. Okay, so it says apply steps 3 and 5, skip steps 4 and 6. I think that means I'm supposed to randomize it. 3. Oh, so we have to remember to remove like the weird non-word words. Yep.
So this numeric, like when you were on AC and it was 17. So that's for all emails, right? AC appears 17 times in all 8,000 emails?
In one, at least one email. It's the maximum. At least one email has 17 ACs. The minimum is 0. So at least one email has 0 ACs.
Okay. All right.
Yeah. A, for instance, the maximum is 48. Like it could appear 48 times in one email and also 0 times in another email. So, okay. Does that answer your question?
Yes, it does.
Okay, great. Then I'm going to remember to randomize it under instance, randomize, apply. And I'm just going to browse again to make sure that I'm, oh. And get rid of this thing. Okay. Then, just like before, I'm going to save as, because it's annoying to have to do that again if something crashes or if I want to go back. And what was I supposed to save it as? Count. Okay. Then you essentially do very similar to the first time. Instead of choosing naive Bayes, which works for only binary or nominal variables. We're going to use naive Bayes multinomial, which works for numeric variables, and start. I'm not going to do it because it'll take a while. And you'll evaluate the results in the same way, actually, identical way, as you do in problem 1. Okay, any other questions about 1 and 2?
Tracy?
Yeah?
I actually have the question for the extra credit one. I don't know if I missed it. So where can I see the descriptive data for like where to find which word are most least indicative of spam? I didn't like go through all those words.
No, exactly. It's not possible. So you need to go into the Weka manual, and it will give instructions on how to sort items or attributes by highest information gain, which is going to tell you the most important. Okay. All right. So moving on to question 3. All right. So this is really the fun part, where we're actually going to try and make this model useful. So you guys talked about in class the arbitrary Weka threshold of 0.5 as the cutoff for whether it's spam or ham. And so now we're going to actually get to play with that and change the threshold and see how that affects the model and its use for our case, our purpose, which is a spam filter. So just like you did in problem 1 or problem 2, you're going to build a model, and it says here, using 34% of the data as test data, which is kind of a roundabout way of saying a percentage split, right? Because we want to train the model on 66%, and then what it's doing is it's testing the model on 34%. So make sure that you do that. I'm just going to quickly open a file. Okay. So even though my computer crashed, as you can see, my data is still beautifully processed, so that's great. And now what I'm going to do is a percentage split. I'm going to change to the target variable and build a model.
I'm not sure if it's only me, but it's a little bit too fast.
This is just the exact same thing that we did before.
Okay.
I'm just catching up. So this is exactly the same thing that I did. I just took the data, set the target variable, and built a model. So before, remember, we were looking at the correctly classified instances, incorrect, and the confusion matrix. And now this is what we really want to play with in problem 3. So what we're going to do is go into more options. For output predictions, we're going to choose CSV and do it again. Okay, so all of this is exactly as it was before, but now we happen to have all of this, all of the kind of more rich data about the model probabilities and the probability of the predicted class. So I'm just selecting all of it. Takes a moment. And I'm going to open up an Excel sheet, and probably shouldn't be this. Well, okay. And then I'm going to paste in. And it's all in one column, as you see. So this isn't super helpful, but Excel has some pretty amazing functionality. If you go to Data, Text to convert text to columns, select Delimited, and we're going to delimit by comma. You can see a preview of what it will be. What it's doing is it's actually making the columns for us. Do you guys know this? Is this repetitive? Or is this helpful? It's helpful. Okay. Great. So we've delimited, and now what we have is the instance number, the actual, the predicted, the error, and the prediction. This is the, I'm going to just change this right now to Weka probability. Okay, so remember, we need to flip around the Weka probability. And I've already kind of done this so that I don't have to do it on the spot, because it's sometimes a little bit confusing. And basically what I've done is I've created an if statement where if C2, which is the predicted value, the predicted class, equals 1, which is ham, but I put in the way that it works if you're creating a formula, an if statement in Excel, is you need to put the text inside quotations, because it has to be exactly the right string. So here it's 1 colon ham. Then it's the Weka prediction. And then here, if it's not, it's 1 minus the Weka prediction. Does that make sense? Yes? Okay, great. So then what you do is apply it to all of the columns. And so you get it to work the entire way down to where it automatically converts. Here, right now I have it sorted in one way, but if we go the other way, you can see here these values are equal because of the if statement. Whereas if we go the other way, it's 1 minus. So this is the first thing you want to do so that you're always working with the total prediction, the real prediction, or probability, rather. This should really say probability, versus the Weka probability. Make sense? Any questions about this? Cool. All right, so I've also kind of made a guide for making confusion matrices. So this is not real data. I just kind of literally made this up. But it's just, you know, about 20 data points, and we're going to use this as a sample for going through how to create confusion matrices. So here I have the instance, the Weka probability, and the model probability. So we're going to mostly be using this here, and the actual outcome. And so the Weka probability is at the 50% threshold. We already know that. And the predicted outcome is also at the 50% threshold. So what we need to do when we're kind of building our own confusion matrix is we're looking at the true positives over the false positives next to the false negatives over the true negatives. And so this is what, if this were in Weka, this is what you would see as the true positives, false positives, the false negatives and true negatives. But what we want to do is actually change that probability threshold, lower and also higher, to see how that affects our key metrics when we're evaluating how well this will work as a spam filter. So basically the way we're going to do this is by building confusion matrices at different thresholds. So here I've made another column for the 30% threshold. And I did this with an if statement, but you actually, well, I can't think of a better way than an if statement. So what it's doing is I'm looking at the model probability. If it's greater than whatever my new probability threshold is, then put 1. If it's less, then put 2. So what I'm left with is kind of for each instance, if a predicted outcome based on a 30% probability threshold. Is there a question? Okay. And I've also done the same thing for 70% probability threshold. As you can see, if 15% is greater than 70%, put 1. If it's less than, or if it's not greater than 70%, then put 2. And so this gives me, again, a whole nother set of what would be predicted outcomes, not at the 50% threshold, but at the 70% threshold. And then what I'm doing is building these matrices, which are basically just counting the number of 1s and the number of 2s if the actual outcome is one way or another, a 1 or a 2. Because what this is saying is for these 7 instances, the actual class was 1 and the predicted class was 1. That's the true positive. In this scenario, the predicted class was 1, but the actual was 2. Those are false positives. It's like you predicted that it would be 1, but it was actually 2. In this box, we have the false negative, which is that we've predicted that it's going to be negative, or that it's going to be 2, but it's actually 1. And then here is the true negative, which is we've predicted 2, and it's actually 2. So all of these different parameters, depending on the use for the model, are going to be of varying degrees of importance.
So we basically have to do one first, we have to do the 50% threshold, but then try doing one of them lower than 50, one of them larger than 50.
Exactly.
And then we'll present it.
And then you're going to decide what is actually the right probability that's going to be best for building a spam filter.
Oh, so you have to keep trial and error and then make the best.
Well, you don't need to optimize it to the percentage. Basically, you want to say, is it better to be at 50, below 50, or above 50?
Okay.
And why it's better. Because remember, like there's a lot of different things that you're looking at. The true positive rate, false negative rate, false positive rate, true negative rates, also the accuracy and the precision. So in the different cases, you want to kind of optimize different different parameters. So you're going to have to explain which parameter you've chosen and why. Why is it the most important parameter? Okay. Any questions? Other questions?
Tracy, will you be sharing this Excel template for us to look into it?
Sure. I would warn you with copy pasting because this isn't actually real data. But I will share it and feel free to use the if statements if they're helpful to you. Yeah. I'll put it up in NYU classes, so you guys can find it. It's going to be called Homework for Excel Guide. Cool. Any other questions?
I have a question. So for this problem, you said it was like problem 1 and 2. I am not quite clear which of them we're using. If we're using the one where we get rid of step 2, I'm sorry, where we took out the binary, or the frequency.
Notate what you did. It's up to you.
So we can use either one.
You'll probably want to use the better one. But it doesn't really make a difference to me. Just notate which one you use. Any other questions?
Tracy, I'm just reminding you that they need to stay with you when everybody.
Okay.
Sharing the screen or something.
Okay. Yep.
Thanks.
All right. So, great. Well, good luck, guys. This homework is actually really fun, so I hope you enjoy it. And I will somehow distribute homework 4. We'll put it in resources, and I'll send it to GroupMe and maybe email out too. Probably will be helpful for everyone to have. If anyone has questions about if statements, I am happy to kind of help out on a case-by-case basis. If you haven't done this type of thing before, it's a little bit confusing. But the other thing to take note of is that Excel actually, like if I want to build an if statement, it'll kind of walk me through it. The logical test is like if this is greater than or less than this, and value of true is like then this, and value of false is else this. So it's pretty easy to kind of figure out, and also there's tons of resources if you want to kind of Google how to use Excel better. I highly recommend it. Cool. All right, well, I'll stay on for kind of individual help, and this ends our office hours.